So, hello everyone, my name's Harry, I'm from Team Hotel, and this is History Phone. So what's it all about? Well, we all know the common scenario when you enter a museum and you want to find out more information about an artifact. It's often the case that we have to hold audio guides up to our faces to listen to information. Well, the goal of Team Hotel was to make this much more interactive for a user. The idea was to create an Android app such that a user can connect with an artifact in the museum that has a Bluetooth beacon installed. And then the idea is that you can open a chat session with these artifacts and ask questions and receive answers. Now, this is a much more interactive way. So what does this involve? Well, obviously, we have the front-end app, which is the entry point of the system. This is what the user is going to use to chat with the artifacts. We have a backend server, which deals with requests sent from the app and also does things such as store metadata for the objects. And of course, we have some sort of NLP module, which is going to do the grinding and processing of the user's input text. And these three things all communicate together to give us our basis of our system. So how do we do it? Well, the app consists of two main screens, a nearby screen and a recent screen. The nearby screen lists in order of distance all of the artifacts that are nearby to the user. If a user clicks on one of these, then a chat session opens where they can ask questions and receive answers. And then we have the recent screen, which simply stores archived conversations in a list of most recently chatted to. So let's take a little bit of a closer look about how we populate that nearby screen. How do we communicate with these Bluetooth beacons? So we start off with a stream of scans, which have a UUID and a relative distance. We then want to do a map left because we want to tie those UUIDs to actual artifact meaningful data. So we plug that into an artifact loader module, which first searches an artifact cache to see if it's present. If that fails, we search a local database. And if that fails, we search a server database because this is the first time that we've encountered this beacon, so we want to pull the metadata freshly. So then we have a stream of scans, but with the associated artifact objects. We then want to group those by artifact, and then we give each artifact its own unique stream. So we have a multi-stream. This multi-stream also deals with things such as distance averaging and errors such as timeouts of scans. We then do a flat map to comprise all of these back together into one single stream, which we can use to populate our nearby screen. So let's talk about NLP. So how is it exactly that the user gains that response from our system? I'm going to hand you over to Charlie, who's going to tell you all about that now.
Yeah, so this is the bit you've all been waiting for. How does the History Phone backend work? So, we're using the Microsoft Language Understanding and Intelligence Service, which is an NLP processing module API. Basically, we send our messages to Lewis, and then Lewis sends back an intent giving a basic summary of the sentence and any entities which are specific things it detects. So let's walk through an example. A user says something along the lines of, "What CPU do you have?" This is sent to the server, which relays it to Lewis. Lewis then says, well, I think the user's trying to find out about the features. And more specifically, I think they want to know about the CPU. We then use this intent and entity pair to query our database, and we get the response, I have an 8-bit, 2 MHz MOS 6502 processor. I'm sure it's all of your favorites. This is then returned to the user. So that's pretty easy, right? Not exactly. So we have to use actual data from users who have asked questions to the app to try and make sure that the app is trained properly. And this means we have to use more than 300 utterances. On top of that, that feeds in then to 40 different responses. And these responses have to be carefully crafted to make sure they, A, have humor, which increases on the sort of more natural ability to communicate with the BBC Micro, which is one of the objects we've used. Also, one of the challenges is the fact that having just an entity and an intent means there's quite a narrow scope. So if you say, what CPU do you have, or do you have an i7 CPU, you'll get the same answer back because you actually get the same intent entity, which means our responses have to be quite broad. They are also designed such that they can prompt the user to ask further questions, which we can actually answer. So I'd just like to say thank you to Ina, who is from Cambridge Museums, who is our client, to the group project organisers, and also to Robert Harle, who provided us with the Bluetooth beacons.